Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0369, indicates an intermittent interruption in the camshaft position, CMP, sensor circuit. The CMP sensor plays a crucial role in engine timing by providing the engine control module, ECM, with vital information about the camshaft's position. In the Honda Civic models from 2006 to 2011, the CMP sensor is typically located near the camshaft assembly, which is aligned with the engine's top end. An interruption in the sensor circuit can result from issues such as wiring faults, loose connections, or a faulty sensor itself. To effectively troubleshoot this DTC, it is essential to start by recording any freeze frame data and onboard snapshots to grasp the vehicle's conditions when the fault occurred. This data aids in understanding the parameters affecting performance and assists in isolating the root cause of the issue. The CMP sensor is integral in determining the position of the camshaft, which synchronizes the timing of valve openings and closings in relation to the engine's pistons. Located adjacent to the camshaft assembly, this sensor monitors rotational speed and position, feeding critical data back to the ECM for optimal combustion timing. An intermittent circuit interruption, as denoted by DTC P0369, can hinder the ECM's ability to manage ignition timing and fuel injections effectively, leading to performance issues. Diagnosing this DTC involves meticulous examination of the sensor circuit and its connections, as intermittent faults can complicate troubleshooting. Understanding the interaction between the CMP sensor, the ECM, and the vehicle's overall engine management system is vital for rectifying the issue. Hence, recording any pertinent snapshot data when the DTC is triggered serves as the foundation for a systematic troubleshooting approach. Several potential causes can trigger the DTC P0369. One common issue is loose or corroded connections at the CMP sensor or the engine control module, ECM. Such poor connections can lead to intermittent signals, preventing the ECM from properly reading the camshaft position. Another possibility is a malfunctioning CMP sensor itself. This can arise from internal failure within the sensor components. Additionally, a damaged CMP pulse plate may also contribute to the issue, affecting the signals sent to the ECM. Inspecting these components thoroughly is crucial in identifying the root cause of the DTC. Each potential cause requires targeted troubleshooting efforts to confirm its validity before proceeding to more complex diagnoses. The presence of any fault points should be documented to maintain a clear record of the troubleshooting progress. Experiencing the DTC P0369 may manifest through various symptoms that can affect the vehicle's performance. One of the primary symptoms is engine misfires, where the engine struggles to maintain a consistent power output. This is often accompanied by rough idling, where the engine may shake or vibrate more than usual when it's at a standstill. Additionally, drivers may notice reduced engine performance. The vehicle may struggle to accelerate or face stalling under certain conditions. Recognizing these symptoms can help in diagnosing the underlying issue more promptly. A close correlation exists between these observable symptoms and the status of the CMP sensor and associated circuitry. Identifying these signs can give mechanics immediate information on where to focus their troubleshooting efforts, reducing diagnostic time and improving repair accuracy. The first step in troubleshooting DTC P0369 involves turning the ignition switch to the on position, specifically to the second position, which engages the vehicle's electrical systems without starting the engine. This position allows the technician to utilize the Honda Diagnostic System, HDS, for further troubleshooting. In this initial stage, It's vital to prepare for clearing the DTC, as this action allows the diagnostic system to refresh and provide accurate readings. This step sets the groundwork for further diagnostics by initially resetting any previous fault codes and ensuring that ongoing conditions are correctly monitored. Clearing the DTC facilitates the collection of fresh data, which helps ensure that any subsequent tests reflect the current status of the vehicle. Proper preparation is crucial for systematic troubleshooting, ensuring that any findings from HDS are valid and actionable. After turning the ignition to on, the next crucial step is to clear the DTC using the HDS. This action is integral for resetting the system and eliminating any stored trouble codes that may no longer be relevant. Clearing the DTC ensures that the technician is working with the latest and most accurate data, free from previous faults that could mislead diagnostics. As the system refreshes, the ECM reestablishes its operational baseline, making this an essential part of the troubleshooting flow. Following clearing, it is necessary to verify that the system responds appropriately during engine operation. This method allows for accurate monitoring of the CMP sensor's performance under current conditions. By effectively resetting the system, the likelihood of detecting intermittent failures increases, facilitating more accurate diagnostics in subsequent steps. In this step, start the engine and allow it to idle for approximately 10 seconds. Observation during this brief period is crucial, as it establishes whether the engine operates normally after clearing the DTC. Such idling serves as a preliminary diagnostic phase where the vehicle's systems, particularly those related to the camshaft position, can stabilize. During these 10 seconds, the HDS can collect valuable real-time data, which assists in understanding the current operational conditions of the CMP sensor circuit. It's essential to ensure that no anomalies are detected within this time frame, as any persistent issues might indicate underlying problems that need exploration. Assessing engine behavior during idle allows technicians to confirm if previous troubleshooting measures have led to any improvement. This observation is a stepping stone to understanding whether further steps in the troubleshooting process are warranted. In this step, it's crucial to check the CMP noise parameter in the data list using the HDS. This check plays an instrumental role in diagnosing whether the CMP sensor is functioning as intended. An indication of 0 counts in the CMP noise signifies that the sensor is not detecting any irregular signals, which typically suggests that the circuit is operating normally. If 0 counts are recorded, you can progress to the next troubleshooting step, which directs you to further diagnostics unprompted by DTC P0369. Conversely, if the counts do not register as 0, it indicates the potential for an intermittent failure within the system. These findings are critical as they dictate the subsequent steps that need to be taken. Therefore, confirming the condition of the CMP noise is essential for determining the presence or absence of faults within the camshaft position sensor circuit. Following the initial checks, it's essential to test drive the vehicle for a few minutes while monitoring freeze data parameters, particularly engine speed and vehicle speed sensor (VSS) readings. This practical step allows the technician to observe the vehicle's performance in real-world conditions, directly correlating with the parameters recorded in the freeze data. Through this evaluation, any irregularities may become apparent, shedding light on whether the DTC P0369 might reappear. By analyzing engine performance under varied conditions, you can comprehensively assess the state of the CMP sensor system. Testing this way demonstrates the effectiveness or failure of any previous repairs, ensuring that an intermittent fault is captured in real time. This practical approach provides invaluable insights that are critical for the troubleshooting process because it directly mirrors the engine conditions under which the DTC was originally triggered. After the test drive, it's again essential to check the CMP B noise in the data list with the HDS. This secondary observation of the CMP B noise helps confirm the earlier findings. Once more, a reading of 0 counts would imply that the circuit is currently functioning properly, suggesting that the previous issue may have been temporary or related to specific conditions. Should non-zero counts appear again, this indicates an intermittent failure, leading to checks for poor connections or loose terminals at both the CMP sensor and the ECM/PCM. Repeating this check over time is critical, as intermittent issues may not always be present under static conditions, but show up when the engine operates under load or speed variations. This ongoing data assessment is invaluable for digging deeper into persistent problems within the sensor circuit and can help pinpoint specific triggers for the DTC. In this step, focus on checking for poor connections or loose terminals at the CMP sensor and the engine control module, powertrain control module, ECM/PCM. This inspection is pivotal, as wiring harness issues or dirt in connectors can easily lead to circuit interruptions, triggering DTC P0369. Inspect the integrity of the connections carefully. Any sign of wear, corrosion, or dirt should be addressed immediately. Utilize appropriate testing tools to verify the continuity and condition of the wiring. If any faults are found during this examination, it may warrant cleaning or securing loose connections, or even replacing faulty connectors. Establishing solid electrical relationships in these components is critical, as they directly impact how effectively engine data is processed and can dictate the overall health of the engine management system. After completing this inspection, determine the next steps based on whether connections and terminals are intact. Next, it's essential to assess the CMP pulse plate for any signs of damage. The CMP pulse plate is a significant component that interacts directly with the CMP sensor. It generates signals indicating the camshaft's position, enabling the ECM to adapt fuel and ignition timing accordingly. Damage to this plate can impede the sensor's performance, leading to the intermittent interruptions indicated by DTC P0369. Inspection should involve a detailed visual check and, if necessary, testing the plate's output signals under operational conditions. If the pulse plate is determined to be damaged, replacement becomes essential to restoring the sensor's functionality. Conversely, if the pulse plate is intact, troubleshooting should proceed to the next steps, ensuring a thorough examination of all critical components involved in the sensor circuit. It is important to recognize this connection and inspect all elements that correlate with the pulse plate to maintain system reliability. Upon identifying a damaged CMP pulse plate in the previous step, the next logical course of action is to proceed with its replacement. A damaged plate may have significant implications on the engine's operational efficiency, disrupting its ability to accurately determine camshaft positioning. Replacing the pulse plate should be conducted meticulously to ensure that all seals and connections are appropriately aligned and secured. Following this replacement, it's pivotal to clear the DTC once more and perform the necessary idle learn procedure for the ECM/PCM, allowing the system to recalibrate based on the newly installed component. This process ensures that the vehicle can adapt to any changes introduced by the new hardware. Confirm that all connections related to the replacement part are secured to avoid future issues. Subsequent steps in the troubleshooting process will enable accurate assessments of the new installation's effectiveness and reliability. If the CMP pulse plate inspection shows no signs of damage, the next step is to replace the CMP sensor itself. Given its crucial role in providing accurate camshaft position data to the ECM, a malfunctioning sensor could trigger the DTC P0369, even if other components are functioning normally. When installing the new CMP sensor, ensure that it is placed correctly and that all wiring connections are secure. Attention to detail during this step is paramount, as improper installation may lead to continuity problems or further issues down the line. After replacing the sensor, it's recommended to clear the DTC again and follow with the idle learn procedures for the ECM PCM. Proper installation ensures that the vehicle can benefit fully from the new component, restoring its ability to accurately monitor the camshaft position and contribute to optimal engine performance. In the final repair verification stage, turn the ignition switch to on second and use the HDS to check for any pending or confirmed DTCs. This step is crucial in confirming the effectiveness of the repair work performed. After the repairs in previous steps, ensuring that DTC P0369 is not present validates that any previous issues have been successfully addressed. If DTC P0369 still appears, further diagnosis of poor connections or loose terminals at the CMP sensor and the ECM PCM is warranted. If no DTCs are present, the troubleshooting process can be deemed complete, and confirmation that the vehicle is operating as expected can be provided. Continuing to monitor the system in subsequent drives can provide assurance of the repair's success. Documenting the findings and any additional DTC responses will maintain a comprehensive service record and guide future diagnostics if needed. Engaging in preventive maintenance is essential in managing and avoiding issues related to DTC P0369 in the future. Regular inspections of the CMP sensor and its associated circuitry can significantly minimize the risk of intermittent failures. It's advisable to periodically check the integrity of the sensor connections and surrounding wires for signs of wear, corrosion, or damage. Ensuring that all electrical connections are secured and clean helps maintain consistent communication with the ECM. This proactive approach not only supports the longevity of components, but also fosters optimal engine performance by preempting faults. In addition to visual inspections, performing regular diagnostics using an HDS can help catch any issues before they escalate. Investing time in preventive measures pays dividends, as it aligns with the best practices of vehicle maintenance, enhancing overall reliability. In summary, the DTC P0369 indicates an intermittent interruption in the CMP sensor circuit, which can lead to significant performance issues if not addressed. Understanding the role of the CMP sensor, its location, and how it interacts with the ECM is critical for effective troubleshooting. By following a systematic approach, including verifying connections, inspecting components, and carrying out necessary repairs, technicians can effectively resolve this issue. The troubleshooting steps outlined provide a comprehensive roadmap to diagnosing and fixing the fault, aiming for a smooth vehicle operation. Additionally, implementation of preventive maintenance practices is essential in promoting the longevity of the sensor and associated components. With these strategies in place, vehicle owners can ensure sustained performance while minimizing the occurrence of similar DTCs in the future. Please like and subscribe to the channel. See you next time.